as you scale up in the complexity scale, we usually have a better and better fit for the in-sample data. But at some point, the test data is going to be worse. So it's usually the curve goes like this. This is the model error. This is the degree of freedom. We usually get two lines. As you increase the degree of freedom, you're increasing the complexity of the model. So the error of the in-sample data usually decreases. Sometimes it approaches an asymptotic value, sometimes it just keeps going down, right? But what really matters is another line that tells you how much error you get in the test data you don't see during the fitting process. When the degree of freedom is significantly less than the amount of data you have, they two usually agree pretty well. At some point, when the degree of freedom is large enough, they start to diverge. And when the degree of freedom is too large, it can go up. So what really matters is the minimum model error in the test data. So that usually determines how complex of a model you want to fit. And the procedure for determining that degree of freedom or effective degree of freedom, if you use some kind of regularization process, is called a cross-validation. And that's something we'll talk about in the next lecture. All right, any questions on this? So I'm trying to give you a good introduction to this whole field of statistical learning that is pretty rich by itself.
So that point there, it's the minimum of the
out of sample error.
And you consider that to be like more representative of the actual error.
Yes.
And so is there also a way of accounting for the increased like computational cost as you...
This doesn't consider computation cost at all.
Or do you just consider it like the cost is so low that it doesn't matter?
Right, but no, this is simply considering how much error you get out of this model. So
like, is there ever a time when you wouldn't necessarily choose the minimum, you choose something maybe to the left of it so that you decrease computational cost?
You would decrease your computational cost? Maybe, yeah. That's a good question. I haven't really encountered a case like that yet. So usually, like, the quality of the prediction is more important than how much computational resources you spend on performing that prediction. The cost of training usually can be pretty high, especially if you use something a lot more complex than this kind of linear regression. So the cost of actually training the model can be pretty high. But usually the cost of evaluating the model is much, much lower than the cost of training the model. So if you can train the model and you can actually figuring out what that point is involves training multiple models, right? So if you can do that, usually the cost of evaluating the model is low enough that you don't really care that much. But computation cost is a huge consideration when you are actually training the model, which is computing the optimal coefficients. Not so much in evaluating. Yeah, any other questions?
Also, is there like an optimal number, like fraction of your data that you should use for training versus validation?
Yeah, so is there an optimal number of ratio you use for training and validation? I don't know if there is an optimal, but there is usually some kind of a convention in different fields. usually what I'm seeing is that the number of data you use for training is higher than the number of data you use for tests. And by the way, so the most regular practice is split the entire data into 3 categories. So this is the final test that you would never see until the very end of your process, to just give one final number on how good your model is. So after you see that number, you are not allowed to come back and tune your model again. And this is the validation data set that you use to produce that out of sample curve. And this is the training. This is the training data set. Right. So the validation set can be about maybe 15% of the whole thing. This can be like 15% of the whole thing, and this can be like 70% of the whole thing. But these values goes up and down in different practices. Yeah. All right. Any other questions? No, I will see you next Monday.